number 1. Negative 4x cubed, y to the 0, z. Okay, so base by base, I have all my numbers in one place, all my x's in one place, all my y's in one place, all my z's in one place. So that's good. But this is y to the 0 power. Anything to the 0 power is just 1. Now, I don't actually need to write negative 4x cubed times 1 times z, because remember, multiplying by 1 doesn't change anything. So this would be our answer here. Example number 2. 3z to the 7th times negative 4z squared. Alright, so we're going to combine our normal numbers together and our z's together. So 3 times negative 4 is negative 12. Z to the 7th times z to the 2nd. That's z to the 7 plus 2. I'm going to write that out for you since we're still getting our bearings. That's going to give us negative 12z to the 9th. So that is our final answer. It's good policy to box your final answers. Okay, this next one. So the expression that we start with is a to the 5th b c to the 8th over a squared b to the 6th c to the negative 1. Okay, as you can see, we have a negative exponent here, but we actually don't need to deal with it. So let me tell you something. This rule, which we are working on right now, is really, really important in theory, but when we are looking at this, we can actually look at it in a slightly different way. And I know you did in my class, if you were there. Wow, went up. Then you would have heard me talk about this before, but we can look at these actually as teams. Team numerator, team denominator, with the A game, the B game, and the C game. So let's look at our A's first. So we have a to the 5th, a squared. Now, if we're going for the most points possible, which team won, the numerator or denominator? Well, most points, the numerator did. That means our A's in the numerator is where it's going to end up. And how much did they win by? Well, if they had 5 points, they had 2. The A numerators won by 3 points. Okay, now we're going to look at our B's. So if you don't see a power, that means it's just the first power. So you can write in the little 1 if you want. So team numerator, team denominator. Which one won? The denominator. This is 6, that's just 1. So we're going to have B's in the denominator. And how much did they win by? Well, they won by 5 points. And then C's. C to the 8th, C to the negative 1. Wow, this is a game where you can get negative points. So team numerator won, so the C's are in the numerator. And they won by, wow, that's 9 points total. So we can look at simplifying these by thinking of it as a match. Numerators against denominators, and there's a game being played for every variable. Numerators against denominators, a game being played for each variable. Okay, now for this one, you'll get to look more at fractional exponents next class. Woohoo! But for now, remember, power to a power, multiply the powers. 3 times 1/3 is just 1, which is just itself. I didn't give myself a lot of space to box that. Oh, I'll zoom up a little bit so you can reference. Okay, so we have negative 2a a cubed b parentheses 3. Now, don't forget that this 3 distributes. So, when everything is being multiplied, you distribute exponents. Why? Because an exponent sees how many times you're doing it by itself. That's the why. But here's what it looks like. So that would be negative 2 cubed a to the 3 times 3 b to the 3, which is 1 times 3, right? So that would give us negative 8 a to the 9th b cubed. Now, I'm actually going to skip and come back to this one, which I'll show you what the problem is. The problem is this, but I want to review our negative exponents before we go over this. So let's skip on down to our negative exponents, which is right here. Negative exponents problem, 5a to the negative 2. Now, the a squared, oops, just make that an equal sign. The a squared has the negative. The a squared has the ticket. The 5 does not. The 5 needs to stay where it is. It does not have the train ticket. But the a squared does have the ticket. So the a squared can move to the other side. That's a little hard to read. Let me rewrite that bigger. There. So only the terms or the variables with negative exponents get to move because the negative exponent is the ticket. Okay, so sorry about the bells, y'all. So we are going to go ahead and take a look back at this one. We're going to distribute because this is the distributive property. So it's going to go to both, there, numerator, denominator. So, the 2 squared has a negative, so it can travel to the other side. It uses its ticket to cross the fraction bar. 3 squared has a negative, so it gets to travel to the other side. Hopefully they weren't trying to meet each other. 3 squared is 9, 2 squared is 4. So, if we compare and contrast that, here we distributed it just the positive, and so they stayed on their side of the fraction bar. Here we distributed it with a negative, and they had to flip to the other side of the fraction bar. Okay, so let's think about our layering for a second. How can learning exponent rules make my life easier? Well, hopefully looking at this blue, you like seeing just this simplified short version in purple a little bit better than doing all the blue. The blue is what's making this messy, which is okay, because learning is messy. But also, consider, we want to become familiar with those exponent rules. Hopefully we're becoming more familiar. Hopefully you've been pausing and looking at the rules as we work the problems. Now we need to simplify the exponent rules using the reference, so can you do it with your notes? Those things must be done now. And hopefully, well, done after you do your practice, rather. Hopefully we get to the point where we can simplify these exponent expressions by our instincts. Okay, so we're going to do just a couple more examples on the back of this page. It's a little messy, so I'm going to actually grab a clean piece of paper. But you can just use the back because most of you are probably not writing in marker. Or if you are, see, I was actually using scratch paper. So it would be too messy for me to do that. So a couple more examples. So I'm just going to number these. Example 1. So say we have 10x squared y over 8 times negative 2x negative 3y over x to the 4th y. Okay, now this is a lot. Our previous examples were just looking at one of the rules at a time. This, however, has multiple rules going on. So let's give ourselves some guidelines to work within. So, guideline number 1. A variable, or rather, when simplified, a variable should only show up in one place. What do I mean by that? Well, here I have an x here, an x term there, and an x term there. I also have y showing up here, and here, and here. That's no good. They need to show up in only one place. I'm going to actually make this bullet points. Then, numbers need to be in front. And be as reduced as possible. Okay. And because I didn't even think we necessarily need to say this, but just as a reminder, it needs to be all one fraction. Okay, so these rules are going to get you on your way. So, pause if you need to. We're going to solve in purple, because purple is the best color ever. Okay, so I'm going to start canceling top to bottom. Ooh, that actually might also be a good thing to note. You cancel top to bottom, which we've looked at, but just to remind yourself. So for example, fractions. We can see 10 and 8, those are both even, so I can reduce those both. So 10/8, 5/4, okay. Now I see I also have another number over here. I have a -2. So the 2 and the 4, top to bottom, I can cancel. So this would just become a 1. Or if you want to write, you can rewrite it as a -1. And this would become a 2. So don't forget this negative here. And then I'm going to see, okay, I have a 5 on top, a -1, and then a 2. So I'm going to have a -5 over 2. So my numbers are in front, and they're as reduced as possible because 5 is not divisible by 2. Okay, so let's just show a couple of your properties. So these are being multiplied, right, with this little multiplication symbol. So that means we have an addition. So 2 plus -3 for our x's. And then our y's, we have a y. If If we don't see anything, that means they're both to the 1. So that's 1 plus 1. On the bottom, there's nothing to combine on the bottom. This would be x to the negative 1, y squared. Now we do that fun little game, because our variable should only show up in one place. So, our numbers. Now, numerator against denominator, and there's a game played for every variable. So, denominator wins by 5 points. Then here, numerator wins by 1 point. So anything to the 0 power just cancels out. Now, I'm going to go ahead and take care of these tickets. So this y cubed wants to cross over. This y squared wants to cross over. Numerator and denominator. You can think of this either as subtracting or canceling. Remember, it's numerator against denominator. The denominator here would win by 1, so I don't need to write it. And you need to have a placeholder. Don't forget placeholder 1s. To clarify in your fractions. Okay, 2 more examples, y'all. Also, one brief thing to note, same as up here as down here with that little multiplication symbol. When multiplying 2 fractions, essentially you can look at that just as one fraction, right? So zoop, and they just multiply numerators by each other and denominators by each other. Okay, go ahead and pause. I want you to solve these on your own. Okay, so hopefully you have solved these on your own. Take a look and see if you got what I got. Now you may not have written out all the steps the way I did, but that's one reason I wanted you to try it before I showed you my answers, because there's more than one way to show the process as long as you are doing the right rules, the exponent rules. Also note 1 to any power is just 1, and we don't need to show 1 in the denominator, just in the numerator. Okay. Alrighty, y'all. So, I hope you remember these rules. I hope you get used to, sorry, I put it on a different page, to how these can make your life easier. And the more you use them, the more comfortable you'll become with them, the faster you'll be able to solve these. So, we went through both the rules, where the rules came from, and we showed examples of that rule by itself. We also showed examples of mix and matching the rules to solve individual expressions, rather to simplify. There was no solving, only simplifying. Solving requires an equal sign. We don't have any. Simplify, simplify, simplify. We talked about a couple of different sort of guidelines of how to get you where you need to go. And I hope that y'all are not too worried about the taking of notes as to whether you are using a blank piece of paper, if that's all you have, or whether you are using printed notes. It's all the same material. The only thing I would tell you is make sure that you are writing things down, because when you involve both your eyesight, your ears listening, and your hands writing, the more senses that go into a learning process, the better your brain remembers it. All right, y'all, you're wonderful. Keep learning.